Hello and welcome to Math with Mrs. Becker. Today in calculus, we are going to finish up section 6.3 by looking at some real life scenarios. Remember in 6.3, our main focus is working with what is called the fundamental theorem of calculus. What that means is that we will find the antiderivative of a function. Once we find the antiderivative, you will fill in numbers from the integral. It will always be take the top number, fill it into the antiderivative, find that value, minus, then fill in the bottom value into the antiderivative, subtract the two. Here are three examples of when you might actually use this in real life. A rocket is fired vertically into the air. Its velocity at t seconds after liftoff can be given by this function, and it is in meters per second. Describe a region whose area represents the distance the rocket has traveled from t equals 40 to t equals 100 seconds. When they say to describe, you're not actually finding the solution, you are setting up the definite integral. So this is what I mean, okay? So you're just setting it up. We're going from 40 seconds to 100. Remember, it's always the smallest number on the bottom, the largest number on the top. Our function is the velocity, so it's 6t plus 0.5. Since we're finding an antiderivative, we need to indicate that our function is a derivative by labeling it dt. That's all you're doing for the describe portion. Now they want us to compute the distance. It's going to tell us how many meters that rocket actually flew, which is super cool. So you find the antiderivative of each piece. So antiderivative of 6t dt plus antiderivative of 0.5. There are no t's, so I'm going to go ahead and put t to the power of 0 dt. This t, since I cannot see an exponent, means that it actually has a 1. If I add 1, the new exponent will be a 2. You take that and you divide it. So this is 3t squared plus. This exponent was a 0, so when I add 1, it becomes 1. If I divide by 1, 0.5 divided by 1 is 0.5 t plus c. So here is your antiderivative. Now we want to calculate that from 40 to 100. So I fill in 100, find the value, then I'll have to fill in 40 and find the value. Excuse me. First sneeze, I think, on a video. Okay, so 3 times 100 squared plus 0.5 times 100. If I fill that in, this is 30,050 plus c. Minus if I fill in a 40. So I'm going to change this to a 40. 3 times 40 squared plus 0.5 times 40. There we go, and make sure I got that. There we go. I get 4,820. Again, it's an antiderivative, so we have our plus c. The minus sign has to go into the entire second group. So 30,050 plus c minus 4,820 minus c. Positive c, negative c. The c should always cross off. So the meters that this rocket traveled between 40 and 100 seconds is 30,050 minus 4,820. It traveled 45,230 meters. That's how far the rocket traveled between 40 and 100 seconds. Okay, here's another example. During the early 1970s, the annual worldwide rate of oil consumption was given by this function right here, and it is in billion barrels of oil per year. T is the number of years since the beginning of 1970. Okay, so when T is 0, we're talking about 1970. Determine, okay, or describe, as it was in the first one, determine the amount of oil consumed from 1972 to 1974. What they want you to do initially is just set this up. So I have a definite integral. 1970 is 0, so 1972 is 2, 1974 is 4. So it's always the small number and the largest number. Our function, 16.1e, to the 0.07t to show that this is a derivative, so that way I can go backwards, you have to label it dt. So this is the formula that we would use. Now it says to find the answer to part A. So I have to find the antiderivative of 16.1 e to the 0.07t. Remember, when it's an e term, the e term along with its exponent is going to remain the same. Now you find the derivative of the exponent, which is 0.07. You would divide that by the original number. So if I take 16.1 divided by 0.07, this is 230. Much nicer number to work with. So I would go ahead, divide those. The e term stays the same. Because it's an antiderivative, it's plus c. We are calculating the billions, sorry, it's in billions, billions of barrels used from 72 to 74. So the way I do that is I have to go ahead, take my antiderivative, fill in a 4, find the value, then do the same thing, fill in a 2 and subtract. So if I have 230 e to the 0.07 times 2, or sorry, we're going to put in a 4 first, 4, close that. I have approximately 304.3 plus c minus. Now if I have the 2 in there, because remember it's always the largest value first, this is 264.6 plus c. The negative has to go into both pieces. 304.3 plus c minus 264.6, and now it would be a minus c because the negative went there. Positive c, negative c. 304.3 minus 264.6, it is approximately 39.7, and it's billion barrels of oil. That's how much oil was used between the years 1972 and 1974. So again, the math is the same as what we looked at last week with the fundamental theorem of calculus. We are just taking story problems, setting up the fundamental theorem of calculus, solving it. We have to make sure at the end we label our solutions because it's not just units squared anymore. Okay, last one together. After T hours of operation, an assembly line is producing power lawnmowers at the rate of 21 minus 4/5 T mowers per hour. How many mowers would be produced during the time 2 to 5 hours? So I have 2 to 5 hours. Our function is 21 minus 4/5 T. To indicate that that was a derivative, it's dt. So that is part A. That's how you would calculate it. Now we find the antiderivative. So 21, there are no variables, so I'm putting t squared, or t to the power 0 dt, minus, because it's a minus sign, 4/5 t, I'm going to put a 1 there, dt. Now if I find the antiderivative, this is a 0. So if I add 1, this equals 1. 21 divided by 1 is 21t, minus, if I add 1, this is a 2. So we got to think of this. If I have 4/5 and I divide by 2, that's the same as dividing by 2 over 1. You cannot divide fractions. So it's 4/5 times 1/2, which becomes 4/10, and that reduces to 2/5, t squared plus c. So here is your antiderivative. Now to calculate how many mowers, lawnmowers, were created from hours 2 to 5, I go from 2 to 5. So you're going to fill in the 5, then fill in the 2 and subtract them. So if I go ahead and have 21 times 5 minus 2/5 times 5 squared. This is 95 plus c minus. Now if I change my 5 to a 2, this is, 40 and 2/5, so 40.4 plus c. This negative has to go to both terms. So I have 95 plus c minus 40.4 minus c. Positive c, negative c cancels. 95 minus 40.4 I get 54.6, so approximately 55 lawn mowers. That's about how many lawnmowers they can make between 2 and 5 hours. Okay, so that's kind of cool. That is what the end of 6.3 looks like if you're working towards your bonus points on the exam when we get to the end of chapter 6. There are just 5 questions out of the book that I feel like are good practice on this skill. So if so, you want to go to pages 324, 325 and look at numbers 37, 39, 41, 42, and 47. Hope you had a great time today, and I'll talk to you tomorrow.